The land was dead. Not struggling, not recovering. Dead. Cracked soil, no grass, no insects, no birds. Scientists had the data, the papers, the consensus. This region of West Texas had crossed a threshold that ecologists call a point of no return. The term itself is precise and deliberate. It means what it says. You do not come back from it. Then someone released 51 bison, and 18 months later, researchers stood in that same landscape and went completely silent. What they found wasn't a partial recovery. It wasn't encouraging signs of regrowth. It was something that shouldn't have been physically possible given everything the scientific community understood about degraded land ecosystems. And the moment they started publishing the data, a second question emerged, one that had nothing to do with bison and everything to do with how many other landscapes we've already written off. But before we get to what they actually found, we need to understand what dead land really means, because dead isn't a metaphor. Ecologists use a specific threshold. Once topsoil microbial density drops below a critical level, the biological feedback loop that sustains plant life collapses. No microbes means no nutrient cycling. No nutrient cycling means no root systems. No root systems means the soil compacts, hardens, becomes essentially biological concrete. Rain doesn't absorb. It sheets off. The land doesn't just stop growing things, it actively resists them. West Texas had crossed that threshold years before the experiment began. Every model said the same thing. Without decades of intensive human intervention, soil inoculation, reseeding programs, water redirection, nothing was coming back. They released the bison anyway, and that decision was either going to confirm everything science knew or break it. Here's what you need to understand about the Texas land before the bison arrived. It wasn't just ecologically dead, it was visually, texturally, almost architecturally dead. Aerial photographs from that period show a landscape that looks less like degraded farmland and more like the surface of a dry lake bed, pale, geometric in its cracking, absent. Scientists who studied it described the soil crust as locked. Their word, not a metaphor. The surface had sealed itself against outside interference, and into this locked, sealed, biologically inert landscape, they introduced large, heavy, hooved animals. The logic on paper was almost confrontational. You do not fix compacted soil by adding weight. Any agronomist will tell you that. You do not restore dead microbial communities by disturbing the surface further. The bison shouldn't have helped, except that's where the first crack appears in the official understanding. Within weeks, something started happening that the monitoring team hadn't included in any of their predictive models. The bison weren't just moving through the land. They were interacting with it in a way that was functionally identical to a process that takes natural prairie ecosystems centuries to develop on their own. The hooves were breaking the sealed crust, but not randomly, not destructively. The pressure pattern, the specific weight distribution of a bison's hoof compared to cattle, compared to horses, compared to any domesticated animal, was creating microfractures in the soil surface at exactly the right depth and interval to allow water penetration without erosion. This wasn't something the researchers planned for. It wasn't something they could have planned for, because it had never been documented before. Let's be specific about what happened next, because the tendency is to gloss over this part, and the details are where the story breaks open. Within 6 weeks of introduction, soil moisture readings in the bison movement zones increased by a measurable percentage despite no significant rainfall event. That water wasn't falling from the sky. It was being pulled, drawn from deeper soil layers through the capillary channels the hoof fractures had created. The land was beginning to breathe again, not because anyone had treated it, seeded it, or intervened, but because a large animal was walking across it in the specific pattern that bison naturally walk, which raises the question no one in the initial reports wanted to ask directly. If the land needed bison movement patterns to unlock, How long had it been locked? And what locked it in the first place? The answer to that question reaches back further than the experiment, further than the degradation of West Texas rangeland, further than modern agriculture, and it involves a disappearance that happened not 18 months ago, but 12,000 years ago. We will come back to that. But first, the microbes. Because what happened underground during those 18 months is what silenced the researchers. The hoof fractures and the moisture recovery were surprising. What came next was categorically different. By month 4, soil sample analysis began detecting microbial signatures that should not have been present. Not rare, not unexpected, should not have been present. The specific bacterial communities responsible for nitrogen cycling, communities that require years of stable organic matter accumulation to establish, were appearing in soil that had tested as biologically inert less than 4 months earlier. The lead researcher's note in the field log from that period is worth pausing on. She wrote simply, "These communities do not spontaneously generate, they migrate. Something is carrying them. The bison were carrying them, not intentionally, not in any mystical sense, but in their hooves, in their fur, in their digestive systems. The bison weren't just unlocking the soil, they were seeding it. Every movement across the landscape was a biological delivery event. Think about what that means. These animals, these specific animals, with these specific physical characteristics, were functioning as a living restoration system. A system so precise, so calibrated to the exact requirements of this type of degraded land that no human engineering had managed to replicate it. We had tried. Across hundreds of restoration projects, with controlled seeding programs, with soil inoculation treatments, with precision irrigation, we had tried to do manually what 51 bison did accidentally in 18 months, and we had failed, consistently, to produce results anywhere close to what the cameras documented in Texas. Which is when the second question, the one that had been sitting quietly at the edge of the research, became impossible to ignore. 12,000 years ago, North. America was home to an estimated 30 to 60 million bison. 30 to 60 million. Moving in herds so large that early European accounts describe them as taking 3 days to pass a single point. The ground movement alone, the hoof fall of millions of animals following instinctive migration routes across the continent, was a geological force, a continuous, seasonal, centuries-deep process of soil fracturing, moisture channeling, microbial seeding, and organic matter distribution. Then, within a few centuries, they were gone, hunted to functional extinction. By the late 1800s, fewer than 1,000 remained, and the land, the same land that had hosted this process for 10,000 years before that, began, slowly and then rapidly, to die. We called it drought. We called it overfarming. We called it climate variability. We built entire agricultural policy frameworks around explanations that all had one thing in common. None of them included the bison. But the Texas data now suggests something that changes. The entire framework. The land didn't die because of what we did to it. The land died because of what we removed from it. That is a fundamentally different statement, and the implications extend far beyond Texas, far beyond bison, into every conversation happening right now about land restoration, carbon sequestration, soil health, and the agricultural collapse that soil scientists have been quietly warning about for 2 decades. But before we get there, we need to talk about the Last Supper. In 2024, an AI image analysis system was applied to Leonardo da Vinci's The Last Supper. Not the painting most people have seen in photographs, but the underlying paint layers. The original work is badly degraded. What has been visible for centuries is largely restoration work layered over restoration work layered over the original pigment. The AI wasn't looking at the surface. It was reconstructing what existed beneath it, mapping paint density variations, pigment chemical signatures, brushstroke direction at the microscopic level, and generating a probability model of the original composition. What it found in the underlying layer wasn't a hidden code. It wasn't a secret message. It was something quieter and more structurally unsettling. Several figures in the original composition appear to have been repositioned between the first and final versions, not subtly. The geometry of the scene, the spatial relationships between specific figures, was different in the original layer. Different in a way that changes the meaning of who is positioned where and in relation to whom. The researchers who published this did so carefully. They used the word unexpected. That word is doing a lot of work. The reason this matters is not conspiratorial, it's structural. Da Vinci was not a casual painter. Every spatial decision in his major works was deliberate, often mathematically deliberate. When the AI reconstruction shows that the original composition placed a specific figure in a geometrically central position and that this figure was moved before the final version was completed, the question is not, what secret was he hiding? The question is, why did he change it? And who, if anyone, asked him to? The documentary record of the commission that produced The Last Supper includes correspondence that has never been fully decoded. Letters between Da Vinci and his patrons, that use language contemporary scholars describe as unusually oblique for what should have been routine artistic direction. The AI finding didn't answer that question. It made the question visible for the first time. Which brings us to Nevada. Because what happened in a Nevada cave system, and what happened to the research afterward, follows a pattern that will feel familiar by the time we reach the end of this. In a cave system in the Nevada desert, archaeologists recovered the remains of a human individual who died approximately 10,700 years ago. That date alone is significant. 10,700 years places this individual in the early Holocene, the period immediately following the last glacial maximum. North America was still being populated. The archaeological record for this period is sparse, contested, and deeply political because it intersects directly with questions about who the first Americans were, where they came from, and what that means for existing historical and legal frameworks. The DNA extraction from remains this old is extraordinarily difficult. Degradation, contamination, and preservation conditions all work against a clean result. But the Nevada sample was exceptional. The cave environment had protected the genetic material in a way that allowed for a high-confidence sequencing. The results were published, and then the conversation around them became quiet. Here is what the sequencing showed. The individual did not fit cleanly into any of the established migration models for early North American populations. Not the Beringian land bridge model, not the coastal migration model, not the genetic signature of any currently recognized founding population, lineage. The haplogroup, the specific genetic marker used to trace ancestry, was present in the sample in a form that exists today in only one other regional population cluster. And that cluster is on the other side of the Pacific. This is not a fringe claim. It is in the published literature. What is not in the published literature, what was notably absent from the follow-up coverage and the subsequent research funding, is any serious institutional effort to build on the finding. The paper was cited. Then it was quietly surrounded by papers that contextualized it, qualified it, and slowly moved it toward the margins of the conversation. That is where the Great Salt Lake becomes important. Because what the exposed lakebed revealed isn't just geological, and the reason it's being described in the language of breakthrough rather than the language of archaeology is worth examining. When lake levels drop, they expose what was previously sealed beneath water and sediment. The Great Salt Lake has been receding for decades, but the rate of recession in recent years has exposed sections of lakebed that have not been above water in thousands of years. In those exposed sections, survey teams have documented structural formations that do not match any known natural geological process for that region. linear arrangements, surface scorings at regular intervals, material density variations in patterns. That, in any other context, would trigger an immediate archaeological assessment. They haven't triggered that here. The official characterization of the formations remains geological. The researchers who have raised questions about that characterization are not conspiracy theorists. Several are affiliated with major research institutions. Their objection is methodological. The geological explanation was applied before the formations were fully surveyed, not after. The conclusion preceded the investigation. Now, step back. Bison that accidentally restore dead land by doing exactly what the land evolved to need, and then being removed precisely when the land could no longer sustain their absence. A painting whose original composition was changed before completion, under circumstances the documentary record describes in language designed to obscure rather than clarify. A 10,700-year-old genetic result that doesn't fit the accepted model, and that was published, cited, and then systematically deprioritized. A lakebed exposure that reveals formations the surveying teams are instructed to classify before they finish surveying. These are not the same story. They are not connected by a single theory or a single explanation, but they share a structure. In each case, the evidence arrived first. The official framework arrived second. And in each case, the framework moved faster than the evidence, closing questions that the evidence had only just opened. The Patterson-Gimlin film was shot in 1967 in Northern California. It is 59 seconds of 16mm footage that has never been definitively proven fake, despite more than 5 decades of motivated effort by people who were absolutely certain it was. When a modern AI motion analysis system was applied to the footage, it wasn't looking for the creature. It was looking at the walk. The gait analysis produced a finding that the team described as, and this is a direct characterization, biomechanically inconsistent with any known method of human-in-suit fabrication available in 1967, and consistent with a bipedal primate anatomy that does not match Homo sapiens in several specific skeletal proportion ratios. That finding does not prove what was filmed. But it closes the easiest exit. The easiest exit has always been, it's a man in a suit. The footage is too blurry, too brief, too convenient. Someone built a costume, someone walked in it, someone filmed it. The AI analysis doesn't say that's impossible. It says the walk is wrong for a suit. The hip-to-stride ratio, the knee lock pattern, the shoulder drop during weight transfer. These are characteristics that require either a non-human skeletal structure or a level of biomechanical suit engineering that did not exist in the commercial or theatrical costume industry in 1967, which leaves two possibilities. Either someone in 1967 built a biomechanical suit sophisticated enough to fool a 21st century AI motion analysis system, or the footage shows something that the motion analysis system cannot classify. Neither answer is comfortable. And the research team, to their credit, published both implications without choosing between them. Here is the thread that runs through all of it. The Bison experiment didn't just restore dead land. It demonstrated that the land had been engineered by evolution over millennia to require a specific animal. Remove the animal, and the system collapses. The land doesn't slowly degrade. It locks. It seals. It dies with a precision that looks almost intentional, which means the land we have written off, the millions of acres classified as beyond recovery, may not be beyond recovery at all. It may simply be waiting for what was removed. The scale of that implication is almost too large to hold. Because we are not talking about one experiment in West Texas. We are talking about the grasslands of the American Midwest, the degraded steppes of Central Asia, the dying savannas, every landscape that once hosted large migratory herbivores in massive numbers, and no longer does. Every one of them may be locked. Every one of them may be waiting. The researchers, in Texas didn't set out to rewrite ecological science. They set out to see what would happen. And what happened was this. 51 animals returned to a landscape that had given up. And within 18 months, the landscape had not given up. It had simply been waiting for the right key. The question that no one in the study has answered, publicly, the one that sits at the edge of every press release and every academic summary, is the one that changes the implications entirely. If the land can be unlocked, who decided it should stay locked? There is no clean answer at the end of this. The bison are walking in Texas, and the land is responding in ways the models said were impossible. The paint beneath the Last Supper shows a composition that someone decided to change. A genetic sample from a Nevada cave describes a human being who arrived somewhere they shouldn't have been, at a time when the maps say no one was there yet. A lake bed is exposing formations that are being classified without being examined. And 59 seconds of film from 1967 has survived every attempt to explain it, and now survived the AI attempt as well. These are data points. What they point to, the shape they make when you hold them together, is not a conspiracy. It is something quieter and in some ways more unsettling. It is the possibility that the story we have been told about this planet, and about what has lived on it, and about how much of it we actually understand, is, in ways we are only beginning to measure, incomplete. Not wrong, not fabricated, incomplete. And the difference between those things is exactly the distance between the answer you were expecting and the one that's still coming.